A semiconductor diode is designed to experience the avalanche breakdown is known as an avalanche diode. In power electronics, the avalanche diode can operate at a specified reverse bias voltage. There are several types of diodes available used in electrical engineering. All these diodes are used for a special purpose. The PN junction diode may get damaged by the current concentration and results in a hot spot in reverse bias condition. The junction of the avalanche diode is made in such a way that it prevents current concentration and hot spots to damage the diode. Now, let's understand the construction of avalanche diode. Avalanche diode was constructed from the semiconductor materials. Generally, silicon is used to make the avalanche diode. Except for the doping level, the construction of the avalanche diodes are similar to the Zener diode. In the Zener diode, the depletion region is thin, due to a heavily doped junction. And because of the thin depletion layer of the Zener diode, the reverse breakdown occurs at a lower voltage. But in the case of the avalanche diodes, the width of the depletion region is wide due to a lightly doped junction. Hence, the reverse breakdown occurs at high voltage. The breakdown voltage is set and controlled by controlling the doping level only while manufacturing the diode. The symbol of the avalanche diode is the same as the symbol of the Zener diode. And it is as shown in this figure. Working of avalanche diode, a PN junction diode allows electric current to pass only in forward bias condition. But the avalanche diodes allows the current to pass in forward and reverse bias. Generally, it is used in reverse bias condition. The operation of the avalanche diodes in forward bias condition is the same as the operation of the normal PN junction diode in forward bias. When the diode is connected in reverse bias, the voltage applied is known as the reverse bias voltage. The avalanche diodes operates when the reverse voltage is greater than the reverse breakdown voltage. The voltage at which breakdown occurs is known as the reverse breakdown voltage. If the applied voltage is greater than the reverse breakdown voltage, the diode allows current to pass from the circuit. Similar to a normal PN junction diode, it has two layers, P layer and N layer. The majority of charge carriers are free electrons in the N-type layer. And holes are the majority charge carrier in P-type semiconductor. When a reverse bias voltage is applied to the avalanche diodes, the majority charge carriers move away from the junction. Therefore, the width of the depletion region increases and the majority charge carrier will not allow the current to pass. In this condition, a very small amount of electric current will pass through the circuit due to the minority charge carrier. This current is known as reverse leakage current. When the reverse bias voltage increases, the energy gained by the minority charge carrier increases. And it results in the high-speed movement in the minority charge carrier. This high-speed minority charge carrier collide with atoms and transfer their energy to the valence electrons. This valence electrons detached from the parent atom and becomes a free electron. This is a continuous process. And hence, the number of free electrons increases exponentially. Now, an increase in voltage will sudden increase in electric current. This will ruin the depletion region. An avalanche breakdown occurs. The breakdown voltage at which avalanche occurs depends on the doping level of semiconductor material used. If the doping level increases, decrease the breakdown voltage of the avalanche diodes. There are several applications of avalanche diode. Out of these, some applications are listed here. The avalanche diode is used to protect the electric circuit. It is used to protect the element of the circuit from unwanted voltage. It is used as a white noise generator. The avalanche diodes generates RF noise. In radio gears, it is used as a noise source. Without injuring itself, it can allow the current to pass in reverse bias if the reverse bias voltage is more than the reverse breakdown voltage.